Okay, let's finally get started. So hopefully you guys can hear me in the back. I don't know. Okay, good. This is a total test for this room. Actually, it's not bad. The acoustics aren't too bad so far. Well, I'll have to listen to my videos and find out. So you've been waiting almost an hour to start, and I apologize for that. Make sure you do sign the roster, so at least you get credit for waiting. So it's not total loss for you. You still get credit for attendance for today. Okay, so I want to go over the final exam schedule, the final exam expectations. Hello, and I want to go over a little lecture on lecture 7, which you've probably been looking at for like the last 5 to 10 minutes or so on I/O exceptions. And just to start out with, I want to tell you where you can find the schedule, and I want to tell you a few things about the schedule, because what you're doing right now is you're just making sure you're available. Everybody must show up in person to take the final exam. You can't do it remotely. You can't do it from home. So what you're going to do is you're going to go online, hopefully take a look at, I'm not going to send it out by email, it's a Microsoft Word file. You'll see it on the front of bhacker.com. You'll see the final exam schedule. And the final exam schedule runs, and let me make this a little bigger here. This is how it's going to run. It's happening on, for this particular class, and for the next one, it's either going to be on the 18th or the 25th, which is on a Monday. And then if you're in my Wednesday class, it's going to be on the 20th or the 27th. And there's a couple of weekend options, and I'll show you the schedule in a few minutes. This is this week. So Friday is the 1st of April. It's April Fool's Day. So play a joke on somebody on Friday, and then you can say April Fools after that and get away with it, hopefully. Unless they hate you after that, who knows. But so then we have 1 full week, 2 full weeks, and then we have the final exam week after this week. Which means on Monday the 11th, I will be having what I call a final exam review, which is probably the most important day of the entire term to show up, because I'm going to tell you what exactly is on the final exam. I haven't written it yet, I don't know, but I will know by the 11th, and so that's the best opportunity that you have to get some sort of a feel for it. And the exam itself will be 1.5 hours to 2 hours at the most. If you need more time, you can have more time. It's not like a timed thing. It'll be multiple choice, and it will not require any programming for this particular class. So this is the Object-Oriented Design Java class. So we don't have to do any Java programming. You won't have to worry about that. All multiple choice questions. You will have to look at some source code and answer a question about it. Very similar, but not as difficult as the midterm in terms of the source code samples that you'll have to look at. Most of the questions are going to be theory-based. There's going to be probably about 8 different versions of the exam. There's no telling which one you're going to get. What I'm doing is I'm going to write a pool of about, well, actually I have a pool of about 200 questions. I'm going to go and read through them and see which ones I like. And then randomly generate about 7 or 8 different versions of it, which means, because when you're answering the exam, it'll be, A, B, C, D, pick one of the above, right? So it's too easy to write it on a little cheat sheet and go like, A, B, hand it to your friend. That's not going to work. If you do that, what's then going to happen is, unless they accidentally, somehow, miracle happens and they actually get the same version you have, the numbers of the characters are going to be wrong. So don't worry about that. It's not going to work that way. It's what I've done in the past. I've always had multiple versions of the exams. The take-homes, I don't. The take-homes are always like the same exam that everybody gets, because it's open book, open notes. So this is a little different because it's an in-class exam, and I have to make different copies of it because I have so many students taking it at so many different times. Some of you actually might take it before others take it. And so all of the versions have to be different to make it fair for everybody. If everybody misses the same question, I throw the question out. I will curve it. If everybody does poorly on it, you'll all do better on it. If everybody else does poorly on it. If everybody does great and you do bad on it, well, it's probably not going to work out for you. But hopefully that won't happen. Let me take a look at the schedule real quick to explain how that's working. And the schedule that's been put together, which is available when you download it from that link that I showed you on bhacker.com. Shows, and here's the trick to this whole thing. It's by date, so Monday the 18th, Monday the 25th. On Monday the 18th, the Oracle people, the class after this class, is taking their exam, which means we don't have object-oriented and design class. The class is done. So when the final exam 2 weeks start, the regularly scheduled classes end, which means you don't show up. Believe it or not, I've had students show up. You don't show up for class because we don't have it anymore. I'll announce on our final exam review day, that's the very last day of the class. Then we start the exams. If you want to take, for example, you are in the object-oriented design class right now, and you like Monday the 18th better, or let's say you're in the object orientation class and you're looking at the 25th, and your last name starts with P, and it's running from 3 to 5, but you can't make it. You want to take it at group number 1. What you do is you send me an email message and tell me which group number. So that's how come they have labels on them. So we only have 5 options, group 1, 2, 3, 4, 5. So you send me an email message that says, can I take the exam at group 3 on Monday the 25th? I need to know the date and the group number. I'll write it on a little piece of paper because here's what happens. I've done this before here, and it's been about a year since we've had in-class final exams. 1 or 2 students used to show up, take the exam for like 5 people. So you must bring your student ID, and when you get checked in to take the exam, we cross you off a list. Everybody has to have a student ID, which is why I need to know which group, which day, because then I change you and I put you in a different list. If, for example, your last name starts with A, this is the last name, and you show up in group number 3, well, actually, that would not be a problem, but let's say it's L, and you show up in group number 1 instead of group number 3, your name's not going to be on that list, and we're going to have too many people sitting in the room. So this is not only to organize you and make it more manageable, but this is also to make the group sizes smaller, so you have peace and quiet. You don't have to worry about, not getting a seat. You're going to have a desk. You're going to have a table. You're not going to have to use a clipboard, which is what we ended up doing in the past. I'm going to have the room set up, and these groups have about 45 to 50 at maximum, each one of them, which is why hopefully we won't get too many people switching, but if you do need to switch, you have a schedule conflict, all you have to do is let me know, and I can probably accommodate you, no problem. But with the smaller sizes, we'll be able to do it in a little bit more human fashion. We'll have a table, you'll have peace and quiet. You sit there, and you can take it, and you can spend as much time as you want. If you want to take multiple exams, let's say you're in more than one class, you can take them all in the same sitting. But I need to know that as well, because we need to be able to do some crowd control. If everyone's taking everything all at once, you're going to sit there longer, which means we're going to need to adjust, maybe. So there will be a little flexibility. There's some seats up front if you want to sit up here. There'll be a little flexibility. We actually ran out of seats. Well, except for these 2 seats up front, or these 3. There's a little flexibility, so if you want to take all of the exams all in the same day, that's a good option. You can do that as well. And if you notice in the schedule, I'm running 2 weekend courses. And the first weekend class, which no one has actually requested yet, is on Sunday the 16th, which is the week after the final exam review. If you wanted to on a Saturday, or if you really want peace and quiet, you can do it on a Sunday. If you decide you want to do it on one of these things that says makeup time, I need to know. Otherwise, if I don't get anyone who's making a makeup, I'm not going to show up. So, this is if you want peace and quiet, and you happen to be available on a Sunday afternoon between 10 and 2, that's a good option, especially for working people. People don't want to worry, But so we have a couple. We have the weekend of the 16th and the 17th. I've actually had a lot of students already request this last weekend, which is 4:30 and 5:1. And so I've got a lot of groupings, actually, because I have a lot of students who have already requested that weekend. I don't know why that weekend is so important. Maybe they think they're going to get previous copies of the exam, and they're going to, because this is the last time slot. The last time to take it would be April 30th or May 1st. So all of the exams will be over with by the 1st of May or on the 1st of May. So again, look up by last name, First character of your last name, look up where you fit in the schedule. If you like it, great, show up on that time. If you don't like it, send me an email message. If you send it to the TA, well, it's actually easier, believe it or not, if you send it to me because I have the master list. So I can actually move you on my list so that when you show up, people know that you're supposed to be there. They can check you in. They can essentially give you the exam. So go ahead and you don't have to decide now. You can wait. You can wait all the way up until final exam week if you want. Change your mind the same day. As long as I have, notice of it, that'd be nice. The more advanced notice, the more ability you're going to get that time slot. Are there questions about the final exam schedule? If there's no questions about the final exam schedule, well, there probably is not going to be until you guys look at it. Oops. There we go. That's what I wanted to do. And if there's no questions about the final exam schedule, we'll move right along to this lecture you've been looking at you've been looking at the main page of it for a while. So, if you weren't here last time and you didn't get the memo yet, you don't have to do assignment number 5. That one is extra credit. Assignment number 5 deals with networking and threads. So, the last one you have to do is number 4, which is the one that does the menu. Did I demo that in this class? No. You guys want it? Well, we have choices actually today. We can demo number 4, and I could talk about swing stuff, or we could talk about I/O exceptions and talk about swing stuff next week. But I'll talk about I/O exceptions. Nobody said anything. All right, so we're already here. Okay, so last but not least, this is one of the things to consider when building a program. It's not error control. It's built-in features that's particular to Java that works with Java objects. And the Java objects are built in to the hierarchy to facilitate better management of the running program. So we have things like runtime errors, we have things like I/O errors, we have exceptions that get thrown. And so here's the kind of the hierarchy, and actually you can kind of see it where you've got an overview. This is kind of a simplified version. The main class at the top of the hierarchy is throwable. So when we say throwable, that means we want to catch. We want to throw this exception if it happens. If we don't throw it, we're not going to see it. We're not going to get anything out of the runtime, the Java virtual machine that's going to help us. So these are classes that are specifically designed for better communication with the JVM to facilitate some automatic exception handling for us. So all the exceptions extend the class throwable, which immediately gets split out into 2 branches, or error and exceptions. The error are internal errors and resource exhaustions inside of the Java runtime environment. You can't do anything about that. If the JVM runs out of memory, you're going to get an error. It's going to be an out of memory error or something of that nature. That you can't control. You can't build anything into your program to control the JVM. It's actually kind of the exact opposite. Your JVM is controlling your program, essentially. The exception splits out into 2 branches, exceptions you can deal with, because you can catch. After you throw an exception, you make a call to throw, and we'll see that in a few minutes. You can catch an I/O exception or a runtime exception, and you can actually deal with those from a certain extent. So we have 2 branches that split out from exception. Error is nothing. In fact, if you see the error, this is good for debugging. But you're not going to be able to do anything in terms of error handling. You're not going to be able to do any handling for it. But the exceptions you can work with, and let's take a look at those for a few minutes. So focusing on the exception branch is what most programmers actually kind of look at. And the 2 branches of the exception, exceptions are all derived from runtime exception. Because this is kind of like what ends up happening in any other operating system. The operating system is controlling the runtime environment. And the runtime environment is giving us error, like codes, things that come out. In other languages, we can actually catch exit codes. We can catch things. And here, what we can do is make instances of these classes in terms of how we're going to implement it in our program, and then take and react upon it when something is found. So an example here might be a bad cast, an out of array access, might happen because an error exists in your program, which might be your fault, that you actually, trying to close something before you've opened it. Well, actually, that'd be an I/O exception. It wouldn't be a runtime exception. But let's say in writing past the bounds of an array that you have implemented. So in terms of the ones that those not in the type of a runtime exception would be trying to open a malformed URL. Maybe a URL that doesn't exist, and program is good, but bad things might happen. It may not be your fault. And so we actually have better control, I would say, of the runtime environment than we do in any other kind of programming language. We have this built in because we have a lot of distributed computing capabilities. We can run classes from many different locations. We might not always be able to see what's going on remotely, remote objects. And the error exception and the I/O handling is identical with the JDK than it is with the Java Enterprise Edition and all of the other versions of Java. So checked exceptions, and can you please keep the volume down? I'm not going to be able to yell over everybody in here. We seem to be a little louder than normal. Is it the way that the room is designed or something? I don't know. We'll have to fix that problem in the future. Maybe the sound of the audience gets picked up higher. The acoustics not so good. All right, so we'll make some changes. Maybe we'll switch rooms is what I'm thinking next week. Okay, so those that are not in the runtime exception might be other ones that are not your fault. If you check the exceptions versus unchecked exceptions, we don't have to check exceptions, but when we check them, we can handle them. So unchecked ones, exceptions that are derived from a class error or a class runtime, those we see in the runtime environment. If you've ever, hopefully when you've written your programs, you probably have seen a couple of those already. They'll say runtime exception, class such and such, method not found. Or something happens and it's like real-time, runtime, real-time handling of different events, in which the JVM will kind of spit that out at you and say, hey, look, this class isn't found. Or we have checked exceptions, all the exceptions that are not unchecked exceptions. So if they occur, then they can be dealt with in some way. So we can check it and say, if we have an I/O exception, then ask the user for a different I/O, a different file name. Or if we have this exception, try it again, try a different URL, or making another attempt at it. So the compiler will check whether you provided the exception handler for the checked exceptions, and if that occurs, then it will go ahead and process it. So declaring to throw checked exceptions. So the way that you implement this, did we have something to say? Or?
It's better if we open the door. Everyone has signed.
All right. Okay, it's too hot. Open the door. It is too hot in here. It's getting muggy, actually. We have really bad ventilation in this room.
We don't have.
Actually, please open the door. I don't want to see students falling over. Please open the door. It's okay. It's good. We're working out the kinks. This is day number 1 of the new building. You might have to put something in the door in order to open it. Yeah. I thought we had a foot. I thought we had like a little floor thing. Stopper. Door stopper. All right, we're going to get through this. All right. So we've seen when we create classes, we can extend, we can implement. Now we can throw. So right when we're saying to create the class, we say throws IO exception, throws EO exception, throws something. And that gets written right on the public class, my class, throws IO exception. So the keyword throws tells us that we're going to check for the exception. And so we can check for multiple exceptions. So we have the ability to actually kind of check for IO, comma, check for this, check for that, throw this, comma, this, this, this. So we can string them together. The method of the constructor should be declared to throw exceptions under 2 situations. It calls another method that throws an unchecked exception. It throws an unchecked exception with the throw statement inside of the body. So we can either put it when we're declaring the class or the method, or we could put it in the body of the particular method that we're writing or class. So declare a method or constructor to throw an exception or use exceptions by using throws clause. And here's an example here. We have public file input string s throws, and this is on the method that we're creating for the constructor of the class. in which we're going to throw a file not found exception. We do that, it's particularly trying to catch something that's in the environment. If we don't put that there, the message actually is still out there. We just haven't caught it yet. So the throw says we want to check it, essentially. We don't actually have to create anything. It's already there for us. Multiple exceptions here. We have throw end of file exception or IO exception. So what normally you would have to do is actually kind of look at, see, what am I doing? Am I doing file IO? And the example is right now geared towards file IO. You can throw exceptions for networking errors, for all sorts of different printer error kind of situations. Depends on the type of functionality that the method's performing as to what you're going to throw in terms of checking for the exception. Basically what you're going to do is go online and you're going to look at each one of the exceptions because there's a million of them. Nobody ever sits there and memorizes each one. They kind of look for which one they're going to use. IO and end of file is fairly common, actually. Okay, so she should not declare an unchecked exception after throws. They're going to be outside of the control, or should be avoided completely by correcting your code, hopefully. So you don't use exception handling to substitute good source code. Actually, that's not really the point. So here we have throw. So using throw as throw in terms of to throw an exception. And what we're looking at in this particular slide is right over here, the word throw. So as I mentioned before, we can put it in the method declaration when we say use this particular method. We can put it inside the method body. So we can throw a new end of file exception to say we've hit the end of the file in this particular example. So in this particular method, the method's called read data. It's reading data from a file, and it's going to contain 700 characters. If it encounters the end of the file after 200 characters, then you're going to decide to throw the exception when this bad situation happens by using the throw statement. So the statement that you're looking at is right here. We're making a new instance of a new object, and a new instance of a new object is end of file exception, E. It's going to be equal to a new end of file exception, which means we're creating an instance of an object, and then we're going to throw E. So the word throw in this particular context is what you're supposed to be looking at in terms of what's different about this piece of code. And it's different because it's kind of a key word that just, it's used a lot. I mean, especially like here with the method, where we're taking an input, a scanner input. And I talked about the scanner class in, I think maybe week 2 or 3 when I talked about system out, system in. In the second part of this particular lecture, goes over the scanner and the buffered I/O because you can't talk about exception handling without talking about file I/O, and we haven't talked about file I/O yet, so that's going to be the next topic. So I'm going to kind of leave the scanner class alone at this point and get there. So the entire method is like here, where we have a while loop. If it's end has next, the end of file encountered. If its end is smaller than the length, then throw an exception, essentially, as an example. So using throw. In terms of the concept, in the method body only throw exceptions, which are not the same type of the subtype of the exceptions are declared after throws. So you can mix and match. In this particular example, we have end of file. We're using the same exception. So if they're the same type, after throws in the method header. If you can find an appropriate exception class in the library, make an object of that class and then throw it, essentially, which is what this example is showing you. Otherwise, you design your exception class. You design your own exception class, essentially. If you're going to design your own exception class, then you're going to create new exception types. So just as we saw last week when I talked about, or the week before, the collections, actually I talked about both weeks, in which we created new types of linked lists or new types of lists in general. We can create new exceptions. So we can customize and build on the hierarchy to create new exceptions that might actually happen that we want to go ahead and throw so we can have better control over our program. Exceptions are objects. New exception types should extend the exception class. So we're inheriting from exception. Or one of the subclasses. We don't have to inherit exactly from that. We can do, inherit from I/O exception or end of file exception. And if the end of the file, let's say check for a particular character, if it's an exclamation point or something, we can do something else. Then maybe it means that the file continues into another file or something. So we can kind of build our own logic into what happens. So why create new exception types? Describe the exception condition in more detail, maybe. Actually can provide a different message or a different type of information that might be a different action that might be performed. So suppose that there's a method to update the current value of a named attribute in the object, but the object may not contain such the attribute correctly or currently. You may want an exception to thrown to indicate the occurrence of such situation, and this is an example showing you how to implement that, where you have attribute name, that's a string, and here's our method, no such attribute exception that's going to be thrown. And so we have super going back, no attribute name is equal to name. So we can, in here we're going to extend here, which means we're inheriting from exception, and we're creating no such attribute exception. Just the same way as we would extend from any other class that we might create. We create our own exception, and we can just, basically we could throw this. We can throw this particular exception now in another piece of code after we've created it. So we can make an instance of that object and then throw it. So the type of the extension is not an important part of the exception data. There's a little note on the bottom. Parameters are just exclusively to one type of exception condition, not to others. So it's kind of like any other type of class that you create. You want to keep the activities and the nature of the class kind of in a separate kind of line, and make sure you organize what the exceptions are actually doing. So catching exceptions. So we throw and catch. That's kind of like softball or something, or baseball. Well, actually not really. It's done with a throw clause. So it's kind of counterintuitive if you think about it. So checked exceptions handling is strictly enforced in terms of the throw. If you invoke a method that lists a checked exception in its throws clause, you have three choices. And so you basically say you want to check it by saying throws, which is interesting, because you'd think it would be like check, but they have throws. It's kind of the opposite. That's what I say. It's not really, it's kind of counterintuitive in my opinion. You can catch the exception and handle it. You can declare the exception in your own throws clause, create your own throws clause. Let the exception pass through your method, and you have a finally clause that cleans it up. Clause to clean up the first one. So just kind of like, it's not really a try and catch. It would be like a throw and catch. So the catch, the finally, we'll talk about finally in a few minutes. The catch the exception and map it to one of your exceptions by throwing an exception of the type declared of its own throws clause. So let's see an example of this. Here we go. Are try and catch used together in basic syntax, and if you're a C++ programmer, you're going, oh yeah, this now makes sense, because this is the kind of the traditional way of looking at it. You still have to use throws, but if you're going to explicitly do it, you're going to say try, some statements, catch, here's the exception type 1, exception type 2, whatever exceptions you want to catch, and then you're going to handle it for 1, handle it for 2, handle it for 3, all the way down to the bottom. If no exception occurs during the exception statements in the try clause, it finishes and all the catch clause are skipped, just the same way as in C or C++. Putting the code inside the try block exception either via the throw, because you can still use throw with this. You're supposed to, I say, it's not going to work without it, or indirectly with a method invoked inside of it. So you can skip the remaining. It's just like the case switch. It's just the same way, same behavior that you see with C++ with the try catch. So it's going to skip everything that doesn't if it doesn't find a proper exception. Which means if you've misspelled the exception, if you've got the wrong one in there, you're not looking for the right one, it could actually cause a problem in the end. And so you can kind of go through all of the conditions here, the catch clause. We're going to examine one by one. Appropriate catch clause is going to be used, and then superclass of the type cannot proceed to catch clause with a subclass exception type, so you can't proceed. You can't essentially proceed with a catch in a superclass. So here's an example. I kind of put it all together in terms of the pieces that I've been showing you so far. We got quiet all of a sudden. It's good. All the people that wanted to leave left. All right, so we have read is our method. Try input stream in is going to be a new input stream for a file. I'm going to talk about that next. Actually, I'll show you what the input stuff looks like. We're opening up a file. And integer views is going to be our, in fact, just kind of move ahead a little bit on the file I/O. It works the same way as it does in C or C++. We have a pointer, but we don't actually have a pointer. We create an integer variable that's going to store our file, essentially, and be used as a kind of a tracer, so we don't have to go back and open up the file. Because what we don't want to do, we want to order buffered I/O to an I/O stream. We don't want to open the file, read one bit, close the file, open the file again, read one bit, close the file. Very slow. So the input stream in gives us the ability to open the file. So B is going to be read in everything, input, process the input. This is not the full code for this. And then catch a print stack trace. We're going to actually look at that and to see printed to the screen, essentially what we want to do is capture the I/O exception. And the I/O exception is going to be like, reached into file, or file's empty, or file's corrupted, or wrong file type, or something. Something's going to come out of that, hopefully. Another choice in this situation is to do nothing, but simply pass the exception to the caller method. So we have choice number 1, try catch. Choice number 2, use throws. So throws is going to say, same method, throws I/O exception. Hopefully you can read that. And same code here, same process here. So if you call a method that throws a checked exception, it's kind of blurry. You must either handle it or pass it on. And that link, actually, if you download the lecture, slide set number 7, if you can't read anything on the slide set. The projector, it looks a lot cleaner on my screen here. I can barely read it, actually, off of here. I can barely see what it says. So you can throw an exception with the catch clause. Typically, you want to do this because you want to change the exception type if indicating failure of your subsystem. So we try catch SQL exception. So here we just have try catch IO. We can change the exception clause to an SQL exception, and we can say catch that one. And then we can say throwable SE is equal to new servlet extension, database error, and then we can throw SE here to catch that particular error message or sequence of error messages that might come out of that. So the exception is caught, the original exception can be retrieved. So we have chaining technique, allows us to throw high-level exceptions without the details of the original failure. So we can actually chain them and catch each one of the individual ones underneath them. So throwable E, we get our get cause, which is essentially going to get all of the sub-extensions that are exceptions that are thrown. You're probably looking at this going, I never want to have any exceptions in my program. The problem is it's actually part of error checking. When you start working with file I/O, everybody from even a C or C++ background knows you have to actually look to see if there was an error opening the file. Because if there was, then the program's not going to run effectively. So let's take a look at this finally, which is different. Same concept in other languages, but here's how it's implemented. Instead of a catch, we're using the word finally. That means if we didn't catch anything else finally, something like default on a switch case in C or C++. So you want to do some actions, whether or not an exception is thrown finally. Clause does this for you. So in terms of, what do we got here? Try 1, try 2, catch IO exception, finally, dispose of it, clean it up. So some of the code which will not throw exceptions, but it'll make it. So, and you can read, well, you can't read it, but you can kind of see the logic with that. It's sort of like the default, or, execute this anyway, even if this doesn't happen. Actually, you see finally used a lot, even actually without try catch. You can use it for a lot of different things. It means, in the particular structure, do it anyway as an option if you're going to break things out into different routes. So you use finally clause without the catch clause. As I mentioned just a second ago, sometimes the finally clause can also throw an exception as well. Inside of finally, if you're trying to do something, you can actually throw the exception. So here we have finally. This may actually, if you're trying to close an input that maybe it's already closed, it's going to throw an exception. So we'll just get you better control. Not only, you're not necessarily worried about making a mess out of the runtime environment. You can leave stuff open, because the runtime environment is going to do its own garbage collection, and it's going to go through and sweep all that stuff up anyway. But it might be the difference between did the file get closed too early or something. If you catch it, then you can know, well, nothing got saved. Because when we closed it, it was already closed. So the likelihood that there might be a problem is going to be high or something. So you can kind of use it to see if the logic of your program is designed correctly. So if the try clause throws a stream exception, and the finally clause throws an IO exception, the original exception is lost, and the IO exception is thrown outside instead. A situation you better avoid, essentially. So what you want to do is to go back and chain them all together. Oops, I had them back there. The way this is positioned, not so good for the neck. I can see I'm going to have to make some modifications to this system. All right, IO packages. Okay, well, all right. So believe it or not, the try, the catch, the finally, the throws, that is everything you have to worry about in terms of Java. That is all of the exception handling. Nobody goes through and memorizes all of the different exceptions that occur. So you find the documentation, actually just go online. You'll see it. You'll see which exceptions are the most important ones to catch. The IO package. Let's take a look at that for a second. This is in java.io. So we're switching gears a little bit, picking up a different concept. And now let me just take a look at my time. Oh, we're doing good. We're doing good. We're going to run into the same time as the next one, so you guys don't have to sit here all day. So the package determines the streams. So we have ordered sequences of data that is basically saved in a source or a file that we're going to open. We're going to use it. We have destination streams, input streams, output streams, regular basic file I/O. Major parts, bits, characters. Same thing we have in C or C++. Actually, it's in fact a lot of things in Java come from C and C++. What we have here in terms of the bit streams is one category. Two parent class abstract classes are input stream and output stream. So these are abstract classes. We know what those are already. So we define methods and things that we need to implement when we start building upon these. Oops. Input stream class defines the abstract method. So we have public abstract in, read, throws, IO exception. And when you start looking at the bodies of these methods, then you say, oh, that's why. They're all throwing the IO exceptions for you, which means you don't necessarily have to do it. All you have to do is make a new instance of the input stream. Use it inside of the implementation, it's already throwing the IO exception for you. In terms of an example here would be file input stream class. The method reads 1 byte from a file. So byte versus streams. Byte is byte, byte, byte. Stream is going to be a sequence of characters. So in terms of the byte, the input stream class also contains a non-abstract method to read the arrays of bytes or skip number of bytes. So writing is the same concept, where we have output stream, defines the abstract method to output the particular content. And we have a write, which throws IO exception, and the output class contains non-abstract methods for the task of writing bytes. So although it's an abstract class, it has already implemented the functionality to read and to write. So you don't have to reinvent the wheel in terms of file I/O. You have built-in classes for that. Close the stream after with a close method. Same thing you get in like other languages. So here's some examples. Here on the top we have count bytes as a little program where we're going to count the bytes as we're reading it byte by byte. If we didn't do that, if we did another, which we haven't seen yet, stream, we don't get to see it at a byte level. It runs in faster. So obviously, if you're going to do something byte by byte, you're going to do it because you're going to count words, count information, or you're looking for something. You're going to search for something that's in a file, which is how it comes in handy. And here it's just going through reading in read 1 byte at a time, and then counting the number of sequences, and that's closing it. So here's another example here to translate the bytes, to take each byte that's in the file and do something to it to manipulate it. So if you run the Java translate B to B and enter big boy via the keyboard and output it, say big boy, it'll be capitalized. This one is changing lower to upper cases or something of that nature. If there's a space or something like that, or I don't know. I'm not going to go through the source code. So that's byte by byte, which is essentially the same thing you get in other languages. The character stream, again, we have the reader and the writer, more popular. Because when you're going to do something byte by byte, it's slow. If you're going to do it byte by byte, you're going to actually do something to each one of the bytes. Turn it around, read it, count it, do something with it, translate it. This is more common. You have the reader and the writer. And in terms of here, you have support for methods for byte streams, counterpart, input stream, and output stream. So standard streams are system in and system out. We've seen that already. We've used it. Hopefully you've used it. If not, you're way behind, of course. We have system error that also exists. So this is input, output, error, which is actually the same as like a Unix, where we have the in, out, and the error. We can redirect, actually, too. So it exists before the invention of the character streams. So the byte streams are logically, they can be character streams. Oh, this is interesting. Okay, good. It moves. Okay, so conversion between byte and character streams. Having way too much fun with that. We have the input stream reader and the output stream reader that translates Unicode and byte streams. So we make instances of these particular classes. So read method of input stream reader reads the bytes from their associated input stream. So we get the stream. Now we're reading the bytes from the streams instead of reading the bytes from the file itself. A little easier, a little faster, obviously, because we're working with data that's already buffered, that's already read in. The hardest thing you want to do, the most time-consuming thing, is to actually open up the file and read it. A lot of people read it into a stream and then apply reading it by byte by the stream. So you can essentially get pre-manipulated characters or bytes out of streams. So the read method on the input stream reader associated with the input stream, numbers of characters using appropriate encoding. Write's going to do the exact opposite. It's going to write the output stream. Closing it's going to close it, essentially. Not always desirable. Closing the convention stream also closes the associate byte stream, which means you have to read it in again. So if you're opening up a file, you're going to close the file. If you're opening up an input stream, you may leave it open until you're sure that you're done with it, and then close it. Because then you'll have to end up opening it up again, which is why it's not necessarily desirable. So in terms of sequential access, random access. Depends on how the Java JVM is actually reading the file. So, in fact, even in C or C++, it's actually done the same way. Same way in Visual Basic, actually, in Visual Studio.NET. So in terms of the sequence, the streams, in terms of file input stream, file output stream, file reader, file writer, allow you to treat the file as a stream of input or output sequentially. So those methods are particularly using a sequential access. So this is just the access mode to the physical file. So each file type has three types of constructors associated with it. Takes a string, takes a file, or takes a file descriptor. This is where we go back to C or C++ and go, file descriptor. It's really a pointer to a file. So if we've already opened it, we have a file descriptor, which is usually an integer variable defined that's pointing to that particular file. We don't have to open it up again, which means we can save on our disk access time. Because a lot of the manipulation with files has to do with corruption, avoiding minimizing the number of times you actually have to open up a file from the hard drive, because that is actually time-consuming. Random access file, random access allows you to read and write data beginning at the specific location, doesn't start at the beginning. It's actually the same as random access to a disk versus sequential access to a disk. Are you going to start anywhere you want and start at that point, or are you going to have to start from the beginning and read everything in until you find what you want? So random might actually be a little faster in terms of what it's supporting. So a file pointer is used, which means you have to have a file pointer to supply for it, which means you've already opened up the file. You have everything pointed to, so you have this temporary memory that's storing the file contents, and so you're able to navigate to a particular location. Not a subclass of input stream, output stream, reader, or writer, because it supports both input and output with both bytes and characters. So it doesn't work with the streams. And here's an example of the random access file, where we have file copy. And it's actually kind of showing you how to copy one file from one location to another. It's opening up a file, reading it, copying out, writing it out. So we have public static main. We're actually not doing any throws here. We're relying upon the methods that we're using inside of the classes that we're creating, the instances of the classes to open and close the files. So we have random access file, file 1, file 2, creating objects saying if they're null, and then doing a try. Here's our catch in here, here's our catch in here, and we file not found exceptions, let's say, to catch those. If we put something else in there, like file IO, it wouldn't actually be caught. The only thing we're going to catch is what we specifically, this is a common problem. People will put like end of file exception, let's say, catch this, and it doesn't find it, so it doesn't catch anything. And they go, oh, it doesn't work. Because it didn't find it, it found the file found exception. Or they'll make a typo in this. And then the typo will actually work. And then they go, oh, no. Oh, wow, it doesn't catch it. It never happens. So it's kind of tricky, actually. I would say the IO exception handling is probably the most tricky thing to do. So we have the file class. So it's useful for retrieving information about a file or a directory from a disk. So files and directories are actually treated the same way, same thing as the C or C++ implementation. File object actually represents the path, not necessarily the underlying file, because it's the location where the file was found, and we have a pointer that leads to that location. And it doesn't open the file or provide any file processing capabilities. It's just the pointer to the file. So we have 3 constructors, give me the name of the file, the path is the name, the directory, and the name. So we can add it in. In fact, you can build on this if you wanted to. Come up with your own effect. If you had a special need, you can extend it out if you wanted to. But it's not an abstract class, so you'd actually have to like build your own subclasses out of it. Main methods here can read. Is it readable? Is it writable? Does it exist? Is it a file? Is it not a file? So we can come back and say, well, is it a directory? What is it? And again, you're never going to want to memorize or actually even worry about remembering everything. What ends up happening is just try to figure out, well, what method do I need to open up the file? Well, here it is. Okay, what method do I need to print it? Oh, here, you know. So you can figure out what you need while you're going along. So, added efficiency. Remember I mentioned buffering. In any other language, actually all languages, buffering makes sense because you don't want to go out and read and write all the time. So we have buffered I/O as well in Java, and you see this more common than anything else. People will create a buffer reader. So the buffer reader will read in a file, put it in a buffer, and then manipulate the buffer, and work with the buffered information. And everything comes from the buffer. And then you can just read the file, put it in the buffer, close the file, and then move on, essentially. So the less you have to do with I/O, the better for efficiency. So buffer reader reads the text from a character input stream. Buffering the characters is providing an efficient range of character arrays and lines. To wrap input stream reader inside of a buffer reader, you go. This is like the de facto standard. You're going to see this. This is the method everybody actually uses. Buffer reader in equals new buffer reader. New file stream reader, because we can read it in by stream. We can read it in byte by byte. We want to do stream reader. We put this inside, we nest it so we can load it up into our object for our buffer reader. The buffer reader is going to be the buffer representing the stream that we've read in with the stream reader, input stream reader. So it's nested. I'll wrap the file reader with the buffered reader to read the file in terms of byte by byte. So you can invoke in read line to read the file line by line. So actually, it's really C++. In a lot of ways, the syntax is a little different, but and the I/O exception is a little different, but it's very similar. Here's our buffer reader VR, read a file, and what is this going to do? This is going to take in an efficient reader. It's going to take it and sort it into a buffer, so get a line. While not in the file, keep reading and displaying the lines. Close the file stream, and then catch any exceptions. The last assignment that you don't have to do dealt with file I/O and exception handling, but you don't have to do it. So if this is looking like Greek to you, you don't have to worry about it because unless you want extra credit, you do that assignment, you get extra credit. So I've checked these sources. They're actually still current, and they're still located out here. And what ends up happening is most students will just find the way that works, hopefully using buffered I/O, using buffer reader. Nest it, make sure it works correctly, and then cut and paste every time you need to open up a file. You're using essentially the same code. I mean, it's as easy as sending something to the output. It's a system out or system in, reading input from the screen. So, And that was lecture 7. And we're actually doing pretty good. We'll end the misery at this point. The misery, the agony. So next time we're going to look at. I'm going to do a quick look here. Actually, I have downloaded all of the lectures. Next time we'll be doing. We actually only have 8, 9, and 10 left, and we have 2 weeks. Do we have 2 weeks after this week?
Yes.
2 more weeks. So I'm probably going to do 8 and 9. I might skip one of them. I believe 8 is on. Let me take a look here real quick. 8 is on. 8 definitely next week we're going to do 8. So next week we're going to look at the swing components, and we're going to go over. I'm going to show you how to do the 4th assignment, which is the last assignment you have to do for the course, which is good timing. Lecture 9 is networking, I believe. I'm going to skip 9. We're not going to do 9.
We have the second week.
Yeah,
you said that
final exam review. Yeah. But I can cover more than just the final exam review.
Yeah.
So 9's a no-go. You can skip 9 out of your reading. You don't need it. But I do want to do 10 because I'm going to split on the 11th. I'm splitting it between final exam review and finishing up any lecture I might have left over. I have 2 lectures left. I have 2 class meetings left. One of them, this is only 20 slides. So I want to briefly mention a few things about documentation, Java docs, garbage collection estimates. So, this gives us more of our runtime kind of features. I think because I've made the last assignment optional, I'm going to forego lecture 9, which is on networking. If you want, you can take the client server and the internet course, and it's all about networking in Java, in the Java Enterprise Edition. In this class, I like to briefly introduce it, but at this particular point, I don't really think it's necessary, considering we're not have to do the networking assignment, so we can forego with that one. So next time I'll be covering lecture 8, and then the week after that will be lecture 10, plus the final exam review. So it gives us on schedule. Any questions? You guys have been very patient, given all of the new things. Okay, so we'll end for today then.